Welcome to my 35th tutoring session in A-level chemistry. In this video, I'll talk about valence shell electron pair repulsion theory. Now, what decides the molecule's shape and bond angle? The molecule's shape and bond angle is determined by the repelling force between the negatively charged electrons. And these negatively charged electrons, it can be bonding pair or lone pair electrons. So it is the repelling force between the negatively charged electrons that decides the molecule shape and bond angle. And where do you find these negatively charged electrons? Let's find out. Now the negatively charged electrons are present in the atom. Atom is the smallest unit of an element. It has a central nucleus. It contains positively charged protons and electrically neutral neutrons, with the negatively charged electrons orbiting around the nucleus in their respective shells or energy levels. So you can find the negatively charged electrons orbiting around the nucleus in their respective shells or energy levels. I have color coded the subatomic particles. Proton is positively charged, neutron is electrically neutral, while the electron is negatively charged. As you all know, like charges repel each other, and negatively charged electron is no exception. When a negatively charged electron approaches or comes close to another negatively charged electron, they repel each other in order to maximize the distance from one another. Now let me explain how the repulsion between the negatively charged electrons decides the molecule's shape and bond angle with respect to water molecule. Molecular formula of water is H2O. Now water molecule has two hydrogen atoms and one oxygen atom. The oxygen atom is covalently bonded to two hydrogen atoms, and this is shown by a solid line. A covalent bond is formed by mutual sharing of pair of electrons between the atoms involved in bond formation. So here you find two bonding pairs between the oxygen atom and the hydrogen atoms. The bonding pairs are generally shown or denoted by a solid line joining the atoms involved in bond formation, while the lone pair of electrons on a particular atom is shown as dots. Now oxygen atom has two lone pair of electrons, and these lone pair of electrons, they're also called as unshared pair, as they are not shared with other atoms, and they're also called as non-bonding pair of electrons because they do not participate in any chemical bonding process. And in the water molecule you find two bonding pairs of electrons, and they are so named because they participate in the chemical bonding process. And they're also called as shared pair, as the electrons are shared between the atoms involved in bond formation. So oxygen has two lone pair of electrons, and due to the close proximity with the bonding pair of electrons, there is a repulsion between these negatively charged lone pair and bonding pairs of electrons. And as an outcome, both the bonds are pushed downwards and as a result, the molecule, that is the water molecule, takes the bend shape. So the bend shape of water molecule is the outcome of repulsion between the two lone pairs of electrons on the oxygen atom and the bonding pairs of electrons. So it is the electron pair repulsion that determines the molecule shape as well as the molecule's bond angles. So in case of water molecule, it is the repulsion between the lone pair of electrons on the oxygen atom and the two bonding pairs that forces the water molecule to take the bend shape with a bond angle of 105 degrees. So let's consider for a moment that the oxygen atom in the water molecule has no lone pairs. So in the absence of lone pair of electrons on the oxygen atom, the water molecule will be linear shaped with a bond angle of 180 degrees. So due to the presence of two lone pairs of electrons on the oxygen atom, there is enormous amount of repulsion between the lone pairs and the bonding pairs of electrons. And as a result, the water molecule is forced to take the bend shape with a bond angle of 105 degrees. So now you know how the repelling force between the negatively charged electrons, which could be a bonding or lone pair, determines the molecule shape and bond angle. Now, what is this valence shell electron pair repulsion theory? Now, the valence shell electron pair repulsion theory, it sets forth certain principles, and these principles determine the shape of molecules and their bond angles. The hydrogen atom has only one proton in its nucleus and only one electron in its outermost shell. Carbon atom has 6 protons in its nucleus. There are 2 electrons in the first shell and 4 electrons in the second shell or the outermost shell. In case of oxygen atom, it has 8 protons in its nucleus, 2 electrons in the first shell and 6 electrons in the outermost shell. So what is the valence shell? The outermost shell of an atom is the valence shell, and the electrons present in the valence shell are called the valence electrons. So it is the valence electrons present in the outermost valence shell that participate in the chemical bonding process or in chemical reactions. So the electron pair, it could be a lone pair or bonding pair, and both the lone pair and bonding pair of electrons are present in the valence shell. So what is the valence shell? Valence shell is the outermost shell of an electron, I mean the atom. Now the lone pair of electrons in the outermost shell do not participate in the bonding process, while the bonding pair, they participate in the chemical bonding process. So lone pair do not participate in bonding, while the other electrons in the outermost shell, they participate in the chemical bonding process. So in case of water molecule, you find 2 lone pairs of electrons highlighted in red. An oxygen atom has 2 electrons in its outermost shell that participate in chemical bonding process. Now the electrons that participate in the chemical bonding process are highlighted in violet color, while the lone pairs are highlighted in red color. So there are 2 lone pairs of electrons on the oxygen atom, also called as unshared pair or non-bonding pair. And the 2 bonding pairs are called as shared pair of electrons. Now the 2 electrons in the outermost shell of oxygen atom, they participate in the chemical bonding process, highlighted in purple. A hydrogen atom that has only one valence electron, they participate in the chemical bonding process. So two hydrogen atoms participate in the chemical bonding process with the oxygen atom, resulting in formation of water molecule. Now carbon atom has four valence electrons, so it can chemically bond to four hydrogen atoms. Now the bonding pair will result only after the chemical bonding process. So you don't find the bonding pair before the chemical bonding process. So a bonding pair is generated only after the chemical bonding process. So only after the carbon atom forms four covalent bonds with four hydrogen atoms, you see the four bonding pairs. And remember, it is the valence electrons that participate in the bonding. And what does the valence shell electron pair repulsion theory say? It says that electron pairs, it could be lone or bonding pair, repel each other in order to maximize their distance from one another. And additionally, VSEPR theory, it also says that lone pairs repel other pairs more strongly than bonding pairs. And as a result, a lone pair will push bonding pairs closer together, and this reduces the bond angle between them by 2 to 2.5 degrees for each lone pair present. And I'll explain this part later in the video with respect to the decrease in bond angle in a particular molecule and how the lone pair influences the bond angle. So after the bonding, there is the generation of bonding pairs, and it is the repulsion between these bonding pairs, or the repulsion between the lone pair and the bonding pairs, gives the shape to the molecule. So tetrahedral shape in case of methane molecule, and bent shape in case of water molecule. So the molecule shape and bond angles are determined by the mutual repulsion between these electron pairs. And let me explain with respect to hydrogen, hydrogen chloride, beryllium chloride, boron trifluoride, methane, ammonia, and water molecules. Now, diatomic molecules are linear in shape, irrespective of whether they are homoatomic molecules or heteroatomic molecules. So what are homoatomic molecules? Homoatomic molecules are those where you find bonding between identical atoms, and heteroatomic molecules are those where you find bonding between different atoms or atoms that are not identical. So here homoatomic molecules are hydrogen molecule, oxygen molecule, and nitrogen molecule, while the heteroatomic molecules are carbon monoxide and hydrogen chloride. So generally, irrespective of whether they are homoatomic or heteroatomic in nature, diatomic molecules are linear in shape. And even the number of bonds do not affect this. So there is only one covalent bond between the hydrogen atoms in hydrogen molecule. You find two bonds between the oxygen atoms and three bonds between nitrogen atoms and carbon monoxide molecule. So the number of bonds do not affect the linearity of the diatomic molecule. So in case of triatomic molecule like beryllium chloride, the bond angle is 180 degree and it is linear in shape. So the two bonding pairs in case of beryllium chloride molecule repel each other in order to maximize the distance between the atoms. And this creates a bond angle of 180 degrees. And the lone pairs on the chlorine atom do not affect the shape, resulting in a linear molecule. So in case of water molecule, the water molecule is non-linear or bend shape with a bond angle of 105 degrees. And this is because of repulsion between the bonding pair and two lone pairs of electrons. And in case of ammonia molecule, you find one lone pair on the nitrogen atom, and this results in the ammonia molecule with a trigonal pyramidal shape with a bond angle of 107 degrees. And this result of repulsion between the bonding pair and one lone pair of electrons on the nitrogen atom. And in case of boron trifluoride molecule, it takes the trigonal planar shape with a bond angle of 120 degrees, and this is due to repulsion between the bonding pair of electrons. So in case of boron trifluoride, you don't find any lone pair of electrons on the central boron atom, and there are only bonding pairs, three bonding pairs of electrons between boron and the fluorine atom. And the molecule takes the trigonal planar shape due to repulsion between the bonding pairs of electrons. And in case of methane molecule, it has a tetrahedral shape with a bond angle of 109.5 degrees, and this is due to repulsion between the bonding pairs. So even in case of methane molecule, you don't find any lone pair on the central atom, that is carbon atom. You find only the bonding pairs between the carbon and the hydrogen atom. So totally there are 4 bonding pairs in case of methane molecule, and the methane molecule, it takes the tetrahedral shape due to repulsion between these 4 bonding pairs of electrons. So in case of beryllium chloride, you don't find any lone pair of electrons on the central beryllium atom, and this leads to the linear shape. And in case of boron trifluoride, you don't find any lone pair, or there is no lone pair on the central boron atom. It takes a trigonal planar shape with a bond angle of 120 degrees. And even in case of methane molecule, there are no lone pairs on the central carbon atom, and this leads to a tetrahedral shape due to repulsion between the bonding pairs of electrons. And in case of ammonia molecule, you find one lone pair of electrons on the nitrogen atom, and this leads to trigonal pyramidal shape with a bond angle of 107 degrees, and this is due to repulsion between the bonding pair and one lone pair of electrons. And in case of water molecule, you find two lone pairs of electrons on the oxygen atom, and this leads to the bend shape of the water molecule with a bond angle of 105 degrees. And you can see the significance of this lone pair of electrons. In case of methane molecule, bond angle is 109 degree, and you don't find any lone pairs. And in case of ammonia, you find one lone pair, and as a result, you can see the bond angle has reduced from 109 to 107. And in case of water molecule, you find two lone pairs of electrons on the oxygen atom, and this further reduces the bond angle from 107 to 105 degree. So as the number of lone pairs increases, the bond angle reduces, and this is because of the repelling force of the lone pairs of electrons on the bonding pairs of electrons. And this is how the molecule shape and bond angles are determined by the mutual repulsion between these electron pairs. Don't forget to subscribe my channel, share, like, comment, and watch the full video. Thank you so much for watching my video. I hope you enjoyed it, and I'll meet you in my next interesting tutoring session.